All right. Today we're going to be talking about relational database management systems. We're going to be diving into what is a database, why even have a database when there's plenty of other ways to keep record of things, working with data within Python, and then we're going to go into problems with manipulating data in Python. Now, again, this is just an introductory week, so we're not going to be going into pandas. We're not going to be going into data analytics or any of the other crazy things that we can utilize utilizing Python. Today it's just going to be purely interacting with a CSV, utilizing a CSV reader with Python, and then trying to create classes to interact with the data that we're receiving from a CSV file. All right. With that said, does anyone have any questions over what we'll be going over today? Okay. If there are no questions, then let's talk about what is a database. Can anybody answer that question? What is a database? In your opinion, when you think of a database, what does it do? What is it for? And who maintains it? Let's hear it, Sam.
So a database is pretty much like where they store information. Store information different, maybe that's like a different server, but they just collect all the information.
Okay, so it's a form of,
It's like a library, I would say.
oh, that's a good way to think about it, right? We got maybe a massive library where different records fall in different sections of our database, right? Maybe we have like hey, this is the history section. And then we have I think it's adventure. I know that might be one of those things, right? And um, inside of each one of these sections, we have records, right? Which is just a book. So there we go. We're adding some records into our history section, and it's almost like a library. Now, you utilized an example of a library, and as I'm drawing this out, I'm noticing that I'm already grouping things. So when you think about a database, do we also think that the data that's being stored in this database needs to be organized and set up in some form of way? And if so, why do we think that's important?
I think,
All right, let's hear it, Jacob.
um, well, I know a little bit about like SQL and stuff like that, but I know that like stuff is ordered, like organized in like tables, like you can create tables. So like they're like, how a big data set is broken up into, and you can, like have them organized into like, I guess, like subcategories, I guess, of that whole data set. So like if you, in this example, you could have like, I don't know, if you want to create a table for history, you could have like all history stuff, so, information on specifically history, and then like adventure, you could have an adventure table, and then that would be all within like a whole database or the library in this example, this metaphorical one, I guess.
Nice. Yeah, that's great. Thank you so much, Jacob. So
Yeah.
just like Jacob mentioned, there is a concept of relational data, right? And when we talked about database systems, or when I went into introducing today's topics, I said a relational database management system. So by saying that, we need a way to be able to create records that have some sort of attachment to other records. So in this example, right, we have history and adventure. Well, history and adventure are likely something named genres. Try to do this here. And rather than having adventure, we would have something like books. Now, when I create a record here, maybe what I have is something like a title and ID, right? Where I have my IDs of 1, 2, 3. We'll use numerical values. You'll notice that there are ways to have like a UUID if you want to really make it unique and uniformed and encoded so that it's not exposed. But we'll talk about that later on as we dive into Django. So there we have a book, right? Each book title has a unique ID. Well, each genre would then have a unique ID as well. Now notice that my IDs are repetitive in both of these tables, right? So books and genres may have the same ID sequence, but the ID itself of the record is unique within the table, right? Well, how would these connect in this case? Well, what would happen is eventually, as we continue to create our database, is we would have to have some sort of relation where we can say, hey, this book here matches this genre, and it also matches this genre. Right? And this book here matches this one, and we'll just say that it matches only one genre in this case. Right, so there's our relational database management system, or a small way to think about it. We have organized data that's being placed directly into one single table, right? Or if we want to think about this about OOP, right? We want to represent one object. In one table, we're representing genres. In our other table, we're representing books. And as each one gets created, if we want to create a connection between them, we would have a way to connect them regarding the IDs, which we'll see later on inside of this curriculum. Okay, so now let me propose a different example here. All right, let's say that we are a shipment service. We work off of an island, and we are very unique in different shipment categories in this island. Some of the things that we utilize for shipment are apples. We also have wood. And then the last thing that we utilize for shipment would be something like maple. Right? So there's our three main conductors for trade. But we have several different stores. So let me go ahead and open our shipment table here. Hello. I'm gonna practice from TL draw and getting back into it. All right, but we also have, let's say, 2 or 3 different stores, right? And in these stores, they all sell maple, wood, and apple. Let's go with the example of 2. Now, if we didn't have a database system to be able to manage this information, such as the cost of apple, the cost of wood, and the cost of maple, what would happen anytime that the cost of maple goes up? How many times would I have to update everyone here about the change of maple?
Would it be 2 times?
Yeah, in this case, it would be 2 times, right? Because I have 2 stores. Now, let's say that for some reason, the cost of maple also affects the cost of wood. Well, now I would have to record this 3 separate times. And rather than just making one simple change, I would be making this change individually 3 times, right? Let's imagine that I'm sending some sort of horse out there, right, with a rider, and he has a little envelope and he delivers the envelope. Well, what if these stores are in separate locations? What if this store is, let's say, on the north side of California, and this store is on the south side of California, right? They're completely separate apart. Well, when the cost of maple changes, our rider goes out, he makes it to this store pretty easily. But by the time he makes it to the store that's further away than where we produce maple, the price of maple may have changed again. And once the price of maple may have changed, we're selling all of this maple in the store at an undervalued price, right? So we need a way to be able to effectively communicate to both of these stores and maybe all the other departments that we utilize for production pretty quickly. And also a way for data to stay sustainable around all the departments. Well, that's where a database comes in, right? Because if I have a database that all of these departments can relate to or speak to, and it already has the calculation saying, hey, if maple increases by this much, then I need to know that wood is also going to increase by this percentage. Then the moment I input into that database one time, hey, maple has increased by this much, all three of those communications that we talked about happen once through one individual record change. All right, so that's the importance of the database there. Does anyone have any questions regarding why databases are important or what is a database? All right, if no one has any questions, then before we dive into working with databases, I would like us to go ahead and take some time to, what is happening here? The raise hand reaction. Oh, okay, got it. Zoom update. I would like to take some time to actually go through a CSV example, and let's talk about how we could represent this in a consistent way without a database, right? This should look pretty familiar to us, especially after assessment one. If I want to work with this with Python, how could I represent each one of these rows inside of Python? And how would I ensure that I regulate the data as it's being inputted into the database that we're making with our Python program here?
You could use a class, and then like we did with other classes, you'll add like a method to loop through the CSV file. So class students,
Okay.
like an init method, or the double, yeah. And then you can take all of the student variables, or just all those elements in the header of the CSV file, and make those the elements for the class or the init method. Yep, just like that.
Okay. Awesome. And then let's go ahead and do this. So ID, probably something we want to privatize. I don't think first name really matters. Last name likely doesn't matter, so. And probably the grade is something that we want to privatize as well, because we wouldn't want individual students changing their grade, right? Okay, so we have some private attributes such as ID and grade, and we have some public attributes for first name, last name, and age. Okay, great. And then you said that we would have to create a method to be able to read from the CSV, right? So let's go ahead.
Correct. It could just be, yeah, import CSV, and now you can just call it like CSV process or whatever, or whatever you want to name it. Yeah, load data, and then self, and then as long as that file is going to be the same name, just you don't have to put a file variable. From here, you're going to do with open parentheses, and then do your CSV file name and quotes. And then afterwards, you're going to say as, whatever you want to say, just file, what will be our asf. Now you're going to declare a variable. It's going to be, I don't know, reader equals csv.dict reader. And then in parentheses, put your f. Now, here's where you can include variability. How do we want to store that data or store those instances of data? Do we want to use an array or a dictionary? Usually a dictionary is probably going to be better. So declare a class variable or make a class dictionary or array, however you want to do it. Now, since we did a dictionary, we want to make a for loop to loop through the students. So for row and reader, that'll be good. Now for each row, we're going to want to declare the actual name or the actual key in that dictionary. So that'd be probably good to do the ID. So row ID would be like your key, and then the rest of that data will just turn into a dictionary. So just do star row in curly brackets. and then Quarks will take that data and manipulate it to where each iteration it will take all of that header key and then put that what that header key is in each column or each row and initialize that or instantiate it in your class object.
Might
And
have
now you just have to return. If you want to do class method, that's probably better for your load data. So add the decorator at class method, and then you'll have to include CLS instead of self. And now you can just do return student CL. Yeah, you didn't even have to provide a return statement. You just do that, if I'm not mistaken.
Okay, awesome. So currently this works with the CSV file. And what it does is it builds a dictionary of dictionaries where the key is the ID and the value is a dictionary representing the student row. Is that what we want here? Does anyone else want to throw something here? Okay, my follow-on question would be, why did we create these class attributes in this class if we're never utilizing a class?
That's a good question. I thought with the CLS or the class method, it would make it that. See, this is where my
Yeah.
knowledge on this gets a little blurry. So
Yeah, I think what we want to do is we want to save class instances inside of that dictionary, right? So now
yeah, that's what I was going for,
Oh.
and that's where I got confused.
Got it. All right, awesome. So let's go ahead and run this. And let's print our student.students so that we could see it. So I'm going to go ahead and run Python main.py. And there we go. We have each one of our students for each corresponding ID number. So quick question regarding our ID numbers, what we're storing here. What data type is our ID?
A dictionary.
Class object.
So it looks like we have a dictionary. So a dictionary would be the entire data structure. But each ID here that we see, what data type?
Integer.
Strings. It's a string.
Oh,
Yeah.
string.
Nice. So we are receiving a string. Is that what we want? Or would we want that to be an integer?
We want it to be converted to an integer.
All right, so let's do that. Let's do row ID is equal to integer row ID. All right, and now when we execute it, now we have integers. All right. Okay, awesome. Now, let's go ahead and break this down a little bit more. When we're talking about data, we want to make sure that it's consistent, and we also want to make sure that it's coming in a uniformed standard, right? So for example, currently we just turned all of the IDs into integers, but all of our ages are likely also strings. All right, let's go ahead and print that out. Let's say print students, I want @1 .age. So we get string, and maybe if I utilize the type operator here, it will let me know what kind of type it is. Yeah, so it's telling me, hey, this is a class of string. But that's not necessarily something that I want, right? What if I want to change this using some mathematical operator later on? Well, I wouldn't be able to do so because it's a class string.
So in your dunder method, just change where you have self.age equals age, just put int and wrap your age with the int method. Is that the correct answer?
Yeah, so I could do something like this, right? And essentially, if I'm going to do that, then I should probably do it for ID as well. Let's see now. Okay, well now it comes back as type integer. Awesome. So that's working great. And now if we were to have a student that came through, and let's say instead of having a number, they try to pass in 20, what would our function do? Well, now we get an error. So in order to make this work, we would likely have to have some sort of data check here, right? We would have to say, hey, if row age dot is numeric and row ID is numeric, then I would like to pass it down. Otherwise, I would likely like to print age and ID must be of integer value. Wow, I can't type. Integer, where did I misspell this? Nope, not even close.
You have an
Alright.
extra R there.
Yeah, take out the R before the G.
I knew that. Thank you so much. All right, well, that was embarrassing. Let's go ahead and try this out again. All right, well, now I'm getting an issue here. It's telling me that my issue is in row ID. Integer object has no attribute of numeric. Okay. And that is happening because I had already turned it into an integer prior to. So let me go ahead and change that there. All right, and there we get age and ID must be of integer. Huh. Well, that's good. We were able to account for someone putting in improper data. But what about, first names, last names? How do we make sure that this letter B is always going to be capitalized? How would we handle each one of these edge cases there?
At least for the grade, you can make it is lower. So if they submit it lower or is upper or whatever, or always cast it into upper so it's consistent when you're checking them every single time.
Okay, awesome. So let's go ahead and add that as well, right? So we want to go ahead and maybe have a separate if statement. Yeah, let's have a separate if statement. If row, and then you're saying grade. And we have to say dot is upper. And row grade in A, B, C, D, and F.
You could just probably put dot upper so it's always going to cast it as upper.
Okay, so even if somebody puts in a lowercase letter, got it. So let's do, and in that case, I don't need to do the and statement, right? I could just do if row grade dot upper is in there, then row grade is equal to row grade dot upper. Okay, and then I could say else grade must be of value A, B, C, D, or F. Okay, so let's try that out. Let's go ahead and try to run a lowercase letter there. And instead of 20, let's pass in 22. Okay, so that seemed to have been accepted. It didn't throw any sort of error. And what happens if I put a letter P in there? Well, now it tells me, hey, the grade must be a value A, B, C, D, or F. Okay, awesome. So we were able to kind of diagnose that information. So now we were able to account for integers. We're able to account for the letter F. We already accounted for IDs as well. What about names? How do
Can
I
do is title.
Awesome. So then I come back here and let's do another if statement. Let's say if row. Oh, I guess it wouldn't even be an if statement. It would just be is title, right? I want it to happen back here. Okay, great. So now if I were to pass in inside of the student CSV, something like Cisco Avalon, and I pass it through, and let's actually just take a look at 6 in this case. We can see that Francisco populates with the correct format. Okay. Now, what if there were numbers that were accidentally placed in there? How would I handle that? Because if I run it, it still populates as Francisco, and it actually messed things up by utilizing the title format, right? Because after that one, it also capitalized the S. So how would I handle for numerical integers in here? Let's hear it, Tristan.
You'd have to do another if statement to see if the first name or last name is a letter. So you check if it's alpha.
Okay. So then let's do if row first name dot is alpha. Then I would want to do this. Otherwise, I would like to, and actually let's just include both of these so we don't have 2 separate statements. And nope, we can't include both of them because they're single initially isolated. Right, and if row last name dot is alpha. All right, so now let's go ahead and run it and see what it does. Okay, so now it tells me, hey, all characters in a name must be letters. But it did still assign it into my class. So it accepted the data even though it wasn't in the correct format. So there's obviously a little bit of debugging that we need to do inside of this mess of if-else statements, right? Maybe we need to do a little bit of figuring out when things should be formatted, how we should format it, and when we should notify the user. Now, this is a pretty useful exercise as far as understanding like, oh, hey, this is why databases are so important, because everything that we just did manually, a database already has the capability of doing that for us, right? If I try to input some sort of field into a database that doesn't meet specific restrictions that I have set inside of this table, it will automatically throw an error and say, hey, this I cannot accept. You need to go back, work with this data, fix the data, and then you can load it into this file. Now, sounds a little bit troublesome, right? What if I really need data to get loaded and no matter what I do, like it's going to take me longer to fix all of this data when I could just load partial data and keep working? Sure, but in the long run, if you keep doing all these partial pushes, you're just going to end up with really messed up data. And as we saw here, sometimes it accepts data when it's not supposed to, right? So it's important to utilize an actual reliable system that will enforce data restrictions. Data is extremely important, especially as you start working with more advanced applications. Imagine if you're working with something that has to do with stocks or something that has to do with medical information. A simple data entry mistake could definitely make a big difference in one, the application, and two, possibly a person's life. So it's super important that we are careful with data. Now, the process that we just covered right now is just the simple process of being able to load data from a CSV file. We haven't covered the process of being able to accept data from a user, right? And we also haven't covered the process of creating getters and setters for each one of our attributes up here, because we need to ensure that the data is maintained throughout the durability of the program. It is a considerable amount of code that we would have to be writing from scratch. Now, in the second portion of today's lecture, we're going to be covering how relational database management systems actually fix this problem for us. But this is going to be where we're going to stop for the first portion of our lecture. So before we move on into our break and go into our reading assignments for today, does anyone have any questions over any of the material that I just covered so far? Okay, great. There aren't any questions. I'm going to go ahead and stop the recording. All right. So before we left for our break or to complete our reading assignments, we took a look at how we would create just a loading data function with some sort of validation to ensure that the data that we're receiving is actually valid before it's being placed into our terminal-based program. Now, let's talk about creating a database or actually utilizing PostgreSQL. Before we even go into utilizing PostgreSQL, just like we did inside of our Python file, we created a class. And this class pretty much mapped out our entire student. Well, we're going to do the same thing here for a table for students, but this is going to actually live within something called SQL Draw. I'm going to go ahead and share this link here. Not all of you will have access. I'm pretty sure it's just going to send you to the main SQL Draw page so that you could sign up and make your own account. This is a really useful tool when it comes to SQL. I really like drawing all of my relations here. And as your applications get more complicated, this is going to be a great way to map your entire database out. So let's go ahead and start talking about how we would create this table here. Well, this it kind of does a little bit of our layout here for us. So here we can see that it names it table 1. In this case, I want it to be named student, and I'm going to add a column here that will have a first name. Now, it also allows me to choose what kind of field I want to utilize within this database. So there's a couple of different fields. There's char and there's varchar. You'll notice that both of those accept characters, but they both have the same limitation of 255. So you may ask yourself, well, what's the difference, right? What's the point of utilizing character or varchar? Both of them can take in an argument of a limitation, right? So I can say, hey, I only want this to take up to 50 characters. Now, the difference between character or char and varchar is that, let's say I have this variable set to 50 characters, but somebody only uses 10 of them. The remaining of those 40 characters will just be represented as blank space, but the memory allocation will still be there for all 50 characters. Now, varchar is a lot more flexible because if I put, hey, I only want 50 characters to go in here, but the user input only utilizes 10 characters, then the amount of memory space that will actually occupy will be only for 10 characters, and it won't fill it in with a bunch of blank spaces. All right, and then there's a couple of other things that we can do here that it brings up to us. It's, hey, is this something that should be nullable? Meaning, is this something that somebody should be able to enter the database without this piece of data? And I don't think so. I don't think this is something that should be notable or nullable, excuse me. And it also gives me a couple of other index types, which we'll dive deeper into all of these concepts later on when we go into PostgreSQL. Well, we can see that we have primary keys, we have unique keys, and indexes, which is just a more efficient way of querying a database. So a primary key would be our ID. A unique key would be, let's say we were taking in emails, that would probably be something unique to each student. So we would have that as a unique key. But in this case, we don't have anything really unique. So we'll repeat the process for last name, which again will be a varchar of, let's say, 255 for now. And then we'll repeat the process one more time for age. And in age, again, there's a couple of different options that we have. We have integer, we have big integer, and we have small integer. I don't remember the exact limitations off the top of my head, but big integer allots for more memory space within the database in order to allow there to be a quite literal huge number, right? Small integer allows for a very minute amount of memory space, which only allows for a small numeric value. And then there's integer, which is the happy medium in between these two. So in this case, I'm going to go with integer. Again, this is something that should not be nullable. And then the last option here, which is going to be grade. What kind of variable should I use to hold the value of grade?
Would be char. Maybe.
Okay. Yeah, in this case, we'll utilize char because we know we will always have an input of 1. Right, so there you go. So none of these are nullable. None of them should be blank. And I've just created my small chart here on the right-hand side of what I want my class or my table to look like. So now when I go into creating this into a CSV file, I can actually reference this table to be able to create my table. Well, now let's talk about how we would create a table inside of PostgreSQL. Notice that I'm nowhere inside of Postgres just yet. I'm still just working within my terminal, my regular terminal. I'm not inside of the server where Postgres is running, and I'm working inside the same directory. I'm going to go ahead and create a new file named students.sql. And this students.sql will actually allow you to write SQL queries. Now, the file doesn't get executed, and it only gets executed once it gets ran within a SQL database. All of these are SQL commands. Everything that you write inside of a SQL file, you can also write it inside of the SQL database command line. There's really no difference as to how things are being processed. The main difference as to why people utilize scripts instead of running it all straight in the command line is when you have a script, you have a record of all the different commands that you've utilized to create some sort of output or some sort of join table, right? You want to make sure that you hold on to these records, especially when you're working in the professional environment, because if something goes wrong with the database and the application shuts down because something crashed, you want to be able to provide all the SQL queries that you've ever ran against the database and pretty much allow the person who's diagnosing the problem to find where we went wrong and how to fix the problem, and 2, protect yourself to ensure that it wasn't you that actually took down the database, right? So let's go ahead and create this table. The command here for creating a table is create table. I'm going to name it student. Then I'm going to pretty much open it up as if it were a function, right? It's going to take in an ID, which will be a serial primary key. And we'll cover what this means here shortly. You'll also notice that the capitalization doesn't necessarily matter in SQL. This is just common practice. Again, we said we're going to use varchar for this because it's more flexible and it will not account for extra memory space. All right, so there you go. We have our entire SQL query, right? We're going to create a table. We have my ID, which is a serial primary key. We'll cover what this serial keyword here means here in a second. We have our first name, last name, age, and grade. Now, this SQL query is not completed yet. And when it comes to SQL, there's another language, and there's a couple of other languages that are static type that require an indicator showing, hey, this is the final line of the code. And SQL is one of them. It will not end unless you have a semicolon at the end of your query. And that's the only way it knows that it wants to end. Also, I want to highlight that the last argument in this create table does not have a comma. All the ones previous to it did have a comma at the end, but the very last argument should not. All right, so now we've created a SQL table, or we have a script to create this SQL table. Well, how do we run this inside of PSQL? Well, let's enter PSQL. Okay, let me try again. Oh, no. Is server running locally and accepting connections to that socket.
That same thing happened to me too, because I tried it earlier. I don't know what that means.
Excuse me, everyone. Let me make sure that this is running real quick. Okay, Docker shut down, so that's good. Okay. All right, so the issue that I just ran into is that PostgreSQL was not running. So we can see here that it gives me a status of, hey, this is not running. So now I'm just checking, seeing what's going on to see if I could quickly get it back online. So it looks like we're running into a bit of an issue here. Let me see if I can get a different PostgreSQL server running. Okay, so it looks like that one started. Let me check my services one more time. Oh, and they're both getting errors. All right, I apologize, everyone. I'm gonna go ahead and pause the recording here just so I could debug this. And I don't want to utilize you guys' time while I'm running through this. So if you guys could just give me an 8-minute break and then we'll reconvene and continue on with the lecture. All right, so as I previously mentioned, we have our SQL completely set up here from demos and notes. And now all I want to do is actually put it inside of SQL. So how do we do that? How do we enter SQL? Well, if I just simply type in PSQL, it throws me straight into my SQL terminal. I can create a database and do all kinds of other things in here. But the main thing that I want to do is get familiar with some commands inside of SQL. So for example, \L will show me a list of all the already present databases here. Let me open that up a little bit. So we can see that we have Francisco, we have Postgres, and a couple of templates. All right. \D shows me all tables within my current database. So inside of Francisco Avila, there is no databases. All right. Or excuse me, no data tables. So I could create a database. I can say, hey, I want to create database. And let's just name this school and end it with a semicolon. It'll tell me, hey, database was created. Well, now when I run \L, if I scroll down, excuse me. You can see that right after Postgres, the school database has been created. But I'm not within that school database, right? I'm still within Francisco Avila. So how do I change into there? Well, if I utilize the \C command, which stands for connect, I want to connect to the school database. And now you'll see that my name changed from Francisco Avila to school. All right, so now I'm inside the proper database where I want to execute this script. Great. Well, now how do I execute the script itself? All I have to do is run \I and say, hey, I want to execute students.sql. And you'll see that a create table query comes up saying, hey, this was completed. Well, now if I run \d, I'll have a public student and a public ID sequence. Interesting. Well, remember how we have this serial keyword here? Well, this serial keyword, what it does is it tells PostgreSQL, hey, I want this to be a serialized number, meaning that every time there is an input into this database, I want you to increase by 1. So PostgreSQL doesn't have an automatic background function to do that. So what it does is it creates a separate sequence database, or excuse me, a separate sequence data table that will be in charge of only maintaining the highest last number that was utilized. So once I continue creating more and more entries, that number will only increase. But as of now, because it has never been called, if I wanted to take a look at it, you'll see that it says last value, because it hasn't been called, is 1. And the log count, meaning how many times it's been actually called, 0. And has it been called is false. All right, so that's how it keeps track of how many entries and how to increase the numeric value after each entry. Well, now let's actually make some entries in here. All right, we have the student.csv data. So how do we make this student.csv data enter our file? Well, we do that by adding it into our SQL command here. What I'm going to do is I'm going to run a \copy. I want to copy students from students.sql, or excuse me, .csv in this case. And notice that the delimiter that I'm using, or the quotation marks that I'm using, is just a single quotation. I don't use double quotations inside of SQL. And then delimiter is just, hey, this is how I want, or this is how we are going to identify each value is separated by the CSV inside of the CSV file. And then finally, we'll say, hey, I am also providing the CSV headers. All right. Well, let's try to execute this code. All right. I'm going to run \I for students SQL. Well, I get an error. And that first error is saying, hey, relation student already exists. Where could this error be coming from?
Was it because you created a student table already, but it's empty and you're trying to import the data from students.csv and does it automatically create one when you copy it? Like on line 9, when you say copy student, isn't it creating like a new database or called student there? So you can't have two same name, yes.
Yeah, so that's pretty close. That's awesome. Thank you. So essentially, the first time we ran this script, we already created a table. And we created this table named student. Well, after we ran that script, we added this one line of code, but then we try to execute the entire script again. So it started from the very top. I told it to create a student table, and it said, wait a minute, I already have that. I already have a student table. So it raised an error saying, hey, I already have a student table. I'm not going to create another one that has the same name. And then we get the copy command saying, hey, I successfully copied 6 students from your database or from your CSV file. So now we run select all from students. Apparently I can't spell. Now we get the ID, first name and last name, age and grade, all the way down numerically with each independent student's information. And everything was loaded pretty quickly straight into our database. All right, before I keep moving forward, does anyone have any questions over any of the topics that I've covered up to this point?
Yes, I have a question.
Okay.
So the idea is just to create your SQL file, and then you wouldn't have to do any of this command line input, correct? That is the goal of this. You put that into whatever program you have, and that way it does it all for you in the background. You don't have to go into the terminal, go into SQL, and do all this manually.
Yeah, that's a great question. So that is definitely an additional benefit out of writing scripts. When you go into a deployment environment, the database that you will be working with that is actually deployed or lives on a cloud that is managing client data won't be the same data that you'll be manipulating inside of your local machine. Right. So what you'll do, or most of the time what will happen is you'll write all of these scripts to manipulate data or interact with data inside of your local machine. You'll ensure it works. And then once you know it works, you'll push it up to the cloud, and then the cloud will then have some sort of action set up for continuous integration, where we'll run all of these SQL commands against the actual client-based database. There's different ways of implementing this, but that is definitely one of the biggest, I guess, factors of writing scripts. Does that answer your question, Owen?
Yeah, I was just overthinking.
Awesome.
Thank you.
Of course. All right. So now we've inserted all of these students here, but what happens if we take a look at our ID or our serial ID? Let me make sure that I know what it was called. There you go. So select student ID. Oh, I forgot to select all from. All right, so we're still getting the last value of 1, the log count of 0, and F for false. Huh. Well, I wonder why that's happening. Well, here I noticed that I utilized a copy command. I never utilized SQL's functionality for being able to insert a student. So if I were to, let's say we want to make this a little bit more dynamic, I want to drop table if exists student. So what this is saying is, hey, if this table already exists, I want you to drop it. And then I'm going to create my table all over again. And instead of copying from a CSV file, what I want to do is I want to run an insert command. I'm going to insert data into student with the arguments of first name. Oh, hello. Let me fix that. Last name, age, and grade. And the following values. So here we have John. Jesus, I can't spell. There we go. John Doe, who is 18 and has a letter A for grade. Then we have Jane Smith, who is 19 and has a letter B for grade. Right, we could continue this, but for efficiency's sake, we're just going to call it quits there. So I'm going to insert into the student table these following values. Notice that I'm not including the ID value. Right? I'm not including ID. I'm just simply sending in the first name, last name, age, and grade. And then finally, I want to end my SQL query by saying, hey, I want to select all from student. And I also want to select all from student ID sequential. That way we can watch all of them. All right, so this is going to drop the table because it already exists. It will then create the table of students for us. We're going to insert 2 values into said table. Then we're going to ensure those 2 values actually exist. And we're going to watch the ID sequential increment. Oh, let's execute our script. Again, we're going to run \i students.sql. And let's start at the top of our commands here. So the table was dropped because students already existed. It then created the table. And then it said, hey, I inserted 2 different students into the database. So I successfully inserted 2. All right, we can see our ID of 1 and 2. I never provided 1 and 2. It just did it on its own. It has John Doe with the corresponding values. And if we take a look at the select all from student ID sequential, the last value is now 2. The log count is 31, which I'm not sure why that's 31. And then we can see is called is now true. All right, and we have a question. Let's hear it, Juan.
So I'm assuming it's safe to say that SQL doesn't suffer from the off by 1 error.
The off by 1 error. So you're saying if I remove 1 student row and then I add another one, like it wouldn't conflict? Is that what you're saying?
No, like we have to index from an array starting from 0 in most languages because of the off by 1 error. I think it was something to do with memory. So this one doesn't suffer from that.
That's correct. Yeah, SQL doesn't do it. Awesome. All right. Any other questions over how to insert values into a data table? Okay, so just to do a quick recap over what we've done so far. We've been able to create a schema that will drop a table if exists. We will then create that table, insert some students into the table, select all from students, and select the ID sequential. We don't necessarily need this ID sequential, so I'm going to comment it out. And I'm actually going to input the remaining of the students now. So here we have, and you know what, instead of inputting the rest of them this way, I'm just going to utilize the copy command. All right, so we can see all 6 students have been loaded. Now, what is another benefit regarding SQL, right? If I wanted to grab data out of a relational database management system, or if I just wanted to grab data out of anything, I wouldn't want to have to handwrite a function that meets specific requirements every single time, like we would if we were utilizing just a Python-based program, right? Instead, I would want to have very default arguments or queries that I know that I'm going to be running all of the time and be able to grab information. So we have this select from students, right? That gives us all the information from students. But if I just wanted the first and last name, I could also just pass in the attributes of first and last name and say from student. All right, when I execute this script, you'll see that it returns a table with only the first and last names. All right, now we can also grab information that is filtered. So I can pass in a where argument. And let's say I just wanted to grab all the students that have a letter grade of a B, right? I can say select, and let's just say first name from student, where grade is equal to B. And when I execute this command, it gives me Jane and Michael, which are the only 2 students that have a B. All right, let me go ahead and open up the CSV file so that we can confirm that. So here we have Jane, and here we have Michael, both students with a letter B grade. We can also get counts and group bys. So if we wanted to have a total number of students or a total number of students that actually got a letter grade of B, we can say, hey, I want to select the count of all students where grade is equal to B. And there you can tell, it shows me, hey, there's 2 students that have this, right? And that's how we can select something by count. I apologize. I put that all in the terminal instead of putting it in the SQL script. All right. There's also between arguments that we can run and order arguments that we can run. So if we wanted to see all of our students ordered by last name, I can say, hey, I want to select Paul from student order by last name. And when I go to execute this, you'll see that it orders them by last name, with the exception of Avila. So it seems like because it's a lowercase letter, it got sent to the bottom. And let's go ahead and flip this upside down by adding a descending argument. All right, so by adding a descending argument, you could flip the order element upside down. All right, now the between argument. So let's say, hey, I want to select first name and age from student, where age is between, let's go with 18 and 20. That sounds fair. 18 and 20. All right, so that looks like a pretty English-based query there. It's just grabbing the first name and the age. So there we can see first name and age of all students where their age is between 18 and 20. So that's greater than or equals to or less than or equals to. And you could also limit your output, right? Let's say I want to run the same query, but I only want the top 3. Well, I could limit by 3. And then that way I only get 3 queries handed back to me. All right. And I believe that is it for queries. There is one more complicated or advanced one, which I'm going to be covering here shortly. Actually, let's just go into it right now. So in this query, what we're going to do is we're going to grab a grade. And what I want is the count of how many students have this grade. Now notice that I'm utilizing this as argument. So when I utilize as, it's like writing an alias. So now instead of just showing count up here, it's going to show count or grade count as my header for my table. Then I'm going to say, hey, I want this to come from the student table. And because I am grabbing by grade and I want to know how many students have that specific grade, I need to group all of my output. So I'm going to run the group by, and then it's say, hey, I want to group it by grade. All right, so now I execute my script, and there we can see B, C, F, and A, where 2 students have an A, 2 students have a B, and 2 students are between C and F, for a total of 6. All right. And that is it as far as SQL queries go. There's a couple of other things you can do. There's definitely different mathematical operations that you can run with SQL queries. You can also run and or statements, and you could also run in statements. We're not necessarily going to demonstrate those today. Again, we'll go more in depth into SQL later on in the program, but this is going to be it as far as our introduction. Does anyone have any questions over anything that we've covered during the second portion of our lecture? Let's hear it, Jacob.
What was the DESC command or query?
Descending, and what it does is it flips the table.
Oh, okay, gotcha.
From top to bottom. If you add descending, then it goes from bottom to top.
Gotcha. Thank you.
All right. Any other questions? Okay. In that case, today We've covered why relational database management systems, what is a database, why have a database, working with data with Python, the problems of manipulating data with Python. We then drew our table utilizing draw SQL. I apologize for not having it on this screen. From there, we turned that drawing of a table into a create table query. We wrote a query that will allow us to copy from a CSV file. And we also saw how the insertion method works for inserting data into your table. And then we ran over the different types of basic queries that you can utilize in SQL. Does anyone have any questions over anything that was taught today? Let's hear it, Juan.
I got one. I'm not sure if this will be covered. It's probably going to be covered later, but as to where saving a lot of this database information will go, like the actual data itself, is that something we're going to cover later? Or
So the data itself is going into PostgreSQL. Is that what you're referencing to? Or are you saying where we're going to create the backups for this data and where those backups will be stored?
the backups for the data, and then where the initial data is going to be stored? So it's going to be stored in like PostgreSQL's like data warehouse or something like that?
So
Or am I misunderstanding?
Yeah, so PostgreSQL is a database. So every time you save an entry into Postgres, that's your data, right? So that's where everything's going to be living inside of Postgres. It's going to get encoded inside of Postgres, and Postgres runs that whole encoding method to ensure that it's not, it's trying to add a level of security to your data to protect your clients, right? As far as where that will live, once we go into deployment or production, you'll have one living inside of your local machine, and you'll have a different PostgreSQL living inside of either Amazon Web Services or some sort of other hosting platform that will host a database. And then as far as saving your backup for your data, I personally like using AWS just because you click a box that says, hey, I want you to automatically save backups, and it will keep a log of backup data for you for your site. Does that answer your question, Juan?
Yes, thank you.
Of course. All right. Awesome. If there aren't any other questions, I'm going to go ahead and stop the recording, and then I'm going to stop the share. Let me see.